Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss sulfur allotropic forms. Last class I have discussed oxygen and oxides, simple oxides. Now I am going to discuss sulfur allotropic forms. Sulfur forms numerous allotropes of which the yellow rhombic, which is also called alpha sulfur, and monoclinic, that is also called beta sulfur. These forms are the most important. Sulfur forms numerous allotropes of which the yellow rhombic and monoclinic forms are the most important. Yellow rhombics are also called alpha sulfur, and monoclinic sulfur is also called beta sulfur. The stable form at room temperature is rhombic sulfur, which transforms to monoclinic sulfur when heated above 369 Kelvin. Now I am telling about rhombic sulfur in details, also called alpha sulfur. This allotrope is yellow in color, melting point 385.8 Kelvin, and specific gravity 2.06. Rhombic sulfur crystals are formed on evaporating the solution of Rol sulfur, Rol R-O-L-L, Rol sulfur in carbon disulfide. It is insoluble in water but dissolves in some extent in benzene, alcohol, and ether. It is readily soluble in carbon disulfide. Again, I am telling you, rhombic sulfur crystals are formed on evaporating the solution of Rol sulfur in carbon disulfide, CS2. It is insoluble in water but dissolves to some extent in three solvents: first benzene, second alcohol, and third ether. It is readily soluble in carbon disulfide. Now I am telling about monoclinic sulfur, which is also called beta sulfur. Its melting point is 393 Kelvin and specific gravity is 1.98. It is soluble in carbon disulfide. This form of sulfur is prepared by melting rhombic sulfur in a dish and cooling till crust is formed. Two holes are made in the crust and the remaining liquids poured out. On removing the crust, colorless needle-shaped crystals of beta sulfur are formed. It is stable above 369 Kelvin and transforms into alpha sulfur below it. Conversely, alpha sulfur is stable below 369 Kelvin and transforms into beta sulfur above this. At 369 Kelvin, both the forms are stable at 369 Kelvin. This temperature is called transition temperature. Both rhombic and monoclinic sulfur have S8 molecules, means 8 sulfurs are attached, both rhombic and monoclinic sulfur. Rhombic and monoclinic sulfur both have S8 molecules. These S8 molecules are packed to give different crystal structures. Several other modifications of sulfur containing 6 to 20 sulfur atoms per ring have been synthesized in the last 2 decades. 6 to 20, this is important. Several other modifications of sulfur containing 6 to 20 sulfur atoms per ring have been synthesized in the last 2 decades. In cycloform means S6. In cyclo S6, the ring adopts the Csir form, and the molecular dimensions I am telling you. Molecular dimension means 6 sulfurs are there, then 4 sulfurs are just in the middle, and 1 above and other down, total 6. 4 sulfurs are in the middle and 1 sulfur is above and other sulfur is down. Means in the middle 4 sulfur is there, then above the first 2 sulfur 1 sulfur is there, and 2 sulfur in the middle, down that other sulfur is there, then total 6 sulfur. It is forming just like a chair form. Okay, it looks like a chair form. This is called chair form, S6. And what is the actually bond length? Then bond length is 205.7 picometer. 205.7 picometer. And that is the middle I am talking about. That 4 are there in the middle, then all 4. This SS bond I am talking about. SS bond, middle, in the middle 2. Their bond length is 205, and bond angle is 102.2 degree. 102.2 degree. Okay, and S8, that is ring is the very common ring is S8 ring. Then this S8 ring, now this you can understand 6 is in the middle. 6 sulfur atoms are in the middle. Okay, and it is just like a crown. It looks like a crown. Okay, crown shape, CROWN, crown shape. Then 6 are in the middle, and one sulfur is, you can say, right side above, and other sulfur is left side little above. Okay, and in the middle 6 are there, then 2, 2, 2, then out of this 6, middle 2 is little above. It's like a cap, you can tell, cap or crown, that shape. Okay, and in S8, that is a crown shape, its bond angle is 107 degree, SSS. Okay, that bond angle is 107, and bond length is 204 picometer. SS bond is 204 picometer. This structure you should know, S8 structure is crown shape, and S6 structure is there, that is a chair form. And one more that is there, this is there common molecule at elevated temperature, means at 1000 Kelvin. S2 is the dominant species and is paramagnetic, means third type, common third type, that is the S2. This is a paramagnetic like oxygen. Okay, then this S2 predominant at near about 1000 Kelvin. Okay, this I have told you. Now one question is asked, which form of sulfur shows paramagnetic behavior? This question is asked in almost all exam. Which form of sulfur shows paramagnetic behavior? Then just now I told you, in vapor state sulfur partly exists as S2 molecules, okay, which has two unpaired electrons in the antibonding pi antibonding orbitals like O2, and hence exhibits paramagnetism, means S2 molecules show paramagnetism. This is a very, very important question. Okay. Now I am telling about sulfur dioxide, SO2. Electrop form I told you, electrop form of sulfur. Now I am telling about sulfur dioxide. Preparation I will tell. Preparation. Sulfur dioxide is formed together with a little sulfur trioxide when sulfur is burnt in air or oxygen. Sulfur dioxide is formed together with a little sulfur trioxide, means both are formed, but sulfur trioxide is very less, 6 to 8% only, when sulfur is burnt in air or oxygen. A simple reaction is there. Sulfur, it is solid. Then S plus O2, it forms SO2. SO2 is a gas. In laboratory, it is readily generated by treating sulfite with dilute sulfuric acid. Sulfite means SO3. SO3 2 minus. SO3 2 minus, just like H2SO3. Then that SO3 is there, SO3 2 minus. Then in the laboratory it is readily generated by treating a sulfite with dilute sulfuric acid. Then dilute sulfuric acid means you can write it 2H plus. H plus means acid. Then SO3 2 minus plus 2H plus. In aqueous solution it forms SO2 plus H2O, means liquid water. SO3 2 minus plus 2H plus, it forms H2O plus SO2. Industrially, how will you prepare? Industrially, it is produced as a byproduct of the roasting of sulfide ores, P-1, sulfide, FeS2, ferrous sulfide, FeS2. Then industrially it is prepared as a byproduct of roasting of sulfide ores. Balanced equation, you can write 4FeS2, that is the solid, plus 11O2. It gives two product, 2Fe2O3 plus 8SO2. Again I am telling you, 4FeS2 plus 11O2. It gives two product. First product is 2Fe2O3 plus 8SO2. The gas after drying, this gas SO2 what you got, the gas after drying is liquefied under pressure and stored in steel cylinders. Now I will tell about the properties. Sulfur dioxide is a colorless gas with pungent smell and is highly soluble in water. It liquefies at room temperature under a pressure of 2 atmospheric pressure and boils at 263 Kelvin. Again I am repeating, it liquefies at room temperature under a pressure of 2 atmospheres and boils at 263 Kelvin. Sulfur dioxide, when passed through water, forms a solution of sulfurous acid, means H2SO3, sulfurous acid. Then SO2 is a gas, SO2 plus H2O. It gives H2SO3, means both will be in equilibrium. SO2 plus H2O, it gives H2SO3, and from H2SO3 you can get SO2 plus H2O. Okay, it is in equilibrium. Next I am telling you, it reacts readily with sodium hydroxide solution, means SO2 reacts with sodium hydroxide solution forming sodium sulfite. Forming sodium sulfite means SO3 I am talking about, which then reacts with more sulfur dioxide to form sodium hydrogen sulfite. Two-step reaction. 2NOH plus SO2, it gives NO2SO3 plus H2O, and this Na2CO3 further reacts with sulfur dioxide, means product was NO2SO3 plus H2O. Now in this product, if further SO2 is passed, means Na2SO3 plus H2O plus SO2, it forms 2NaHSO3. Okay, bisulfite, hydrogen sulfite forms. So then sodium sulfite I told you, and then again it reacts with more sulfur dioxide to form sodium hydrogen sulfide, means NaHSO3. Balance equation is Na2SO3 plus H2O plus SO2, it gives 2NaHSO3. In its reaction with water, now water reaction with water, you can say SO2 reaction with water. In its reaction with water and alkalis, the behavior of sulfur dioxide is very similar to that of carbon dioxide. CO2 also behaves same way, okay, like SO2. Sulfur dioxide reacts with chlorine in the presence of charcoal, which acts as a catalyst to give sulfuryl chloride, SO2Cl2. Okay, always remember sulfuryl chloride is SO2Cl2. Then sulfur dioxide reacts with chlorine in the presence of charcoal, which acts as a catalyst to give sulfuryl chloride, that is the SO2Cl2. It is oxidized to sulfur trioxide by oxygen in the presence of vanadium pentaoxide. Vanadium 5 also you can write. Vanadium 5 oxide. Oxide catalyst means vanadium pentaoxide. Then reaction is very simple. SO2 plus Cl2, SO2 plus Cl2, both are gas. It forms SO2Cl2. Sulfuryl chloride is a liquid. SO2Cl2 is a liquid. And second reaction, that is the SO2 plus O2. 2SO2 plus O2. Very simple reaction. It forms 2SO3, means sulfur trioxide. Okay, but it will give sulfur trioxide only in presence of V2O5, vanadium pentoxide. Means 2SO2 plus O2 in the presence of V2O5, it gives 2SO3. This is a gas. Now next I am talking about next properties. When sulfur dioxide is moist, that time it behaves as a reducing agent. When moist, sulfur dioxide behave as a reducing agent. Okay, means it can supply the electron. Reducing agent means supplier of electron. Okay, for example, it converts iron third ions to iron second ions. Okay, it converts iron third to iron second, and decolorizes acidified potassium permanganate. Acidified potassium permanganate, it decolorizes. Color will change. It decolorizes acidified potassium permanganate solution. Okay, then this reaction means decolorization. This is the actually it is a test for the gas, whether gas is there or not, SO2. This is the convenient test for the gas. Reaction, you can see that Fe3 plus plus SO2 plus 2H2O. It gives, now Fe3 plus is converting into Fe2 plus, and it will SO2 will convert into SO4 2 minus plus 4H. Okay, then balanced equation you can write 2Fe3 plus plus SO2 plus 2H2O. It gives 3 product. Actually SO2 here is in a plus 4 oxidation state. SO2, 1 oxygen minus 2, then 2 oxygen minus 4. Then obviously sulfur is plus 4. But in the product it is giving sulfate ion. Then that SO4 2 minus. Then now in this stage, what you will find the oxidation state of sulfur? Then 4 oxygen means minus 8. 4 into minus 2 minus 8. Okay, then S plus minus 8, that is equal to minus 2, because overall sign is minus 2 minus. Then S minus 8, that is equal to minus 2. Then S is equal to plus 6. Then now see here, S was having plus 4, now it became plus 6, means it has donated 2 electron. Hence balance equation you can write 2Fe3 plus SO2 plus 2H2O. It gives 2Fe2 plus. Fe3 plus converted into Fe2 plus SO4 2 minus plus 4H plus. Second reaction is means a decolorization of acidified potassium permanganate. That is the test for sulfur also. Then 5SO2 plus 2MnO4. 2MnO4, 1 minus. KMnO4 is there. You are adding only MnO4. Then MnO4, 1 minus. Then 5SO2 plus 2MnO4, 1 minus plus 2H2O. It gives 3 product. Again, SO2 is converting into SO4. And MnO4, which is a MnO4 1 minus, his oxidation state is Mn plus minus 8 is equal to minus 1. Means here Mn is in a plus 7 state. Plus 7. And now here you are getting Mn in plus 2. Plus 2. Okay. Means now Mn plus 7. Now it has taken electron. and now it became Mn2 plus. Okay, then 5SO2 plus 2 MnO4 1 minus plus 2 H2O, it gives 3 product 5SO4 2 minus plus 4H plus 2 Mn2 plus. Okay, this I have told about the reaction properties. The molecule of SO2 is angular. Remember, angular. Okay, it is a resonance structure, resonance hybrid of two canonical forms, and structure is two canonical forms are both are very easy. SO2, then two oxygens are there, sulfur is in the middle, then one oxygen and sulfur, they are making double bond, and other oxygen is making single bond. Okay, that's why it is angular, SO2. Then now in second canonical form, then where it was a single, now that became double, and what was the double? That became single. Okay, that is the only, both are canonical. S is in the middle. One oxygen left side is double bond, right side oxygen is single bond. Now in second structure, first SO bond is single and second become double. Okay, then this is the structure of SO2. It is angular. Now I am telling the application, usage of sulfur dioxide. Sulfur dioxide is used first in refining petroleum and sugar. It is used in refining petroleum and sugar. Second, use in bleaching wool and silk. Second use is in bleaching wood and silk. And third use is as an anti-chlor, CHLOR, anti-chlor, disinfectant and preservative. Okay, third use as an anti-chlor, as disinfectant and as preservative. Okay, sulfuric acid, sodium hydrogen sulfate and calcium hydrogen sulfate, okay, are manufactured from sulfur dioxide. These many important use all over the world, that is in the manufacture of sulfuric acid, sodium hydrogen sulfite, calcium hydrogen sulfide, etc. And this is prepared from sulfur dioxide. Now next application, liquid SO2 is used as a solvent. Liquid SO2 is used as a solvent to dissolve a number of organic and inorganic chemicals. This I have discussed. These things, uses of SO2. Now I am going to discuss oxo acids of sulfur. Oxo acids of sulfur. Actually, you must know about the oxo acids. Many acids are there of sulfur having oxygen. That's why it is called oxo acids of sulfur. Sulfur forms a number of oxo acids such as H2SO3, H2S2O3, H2S2O4, H2S2O5, H2SXO6, where X may be equal to 2, 3, 4 or 5, means 2 to 5, maybe 2, maybe 3, maybe 4, maybe 5. And other also oxo acids are there, H2SO4, H2S2O7, H2SO5, H2S2O8, H2O8. Then see, many I have discussed, I told about the oxo acids. First, again I am repeating, H2SO3. Second, H2H2O3. First was H2SO3, only one S. Now H2S2O3, 2S. Third is H2S2O4, now one extra oxygen. And fourth one is again H2S2O5, one again extra oxygen. Means here you have seen SO3 means first was only one S, O3 was there, and after that second one H2S2, S increase, double, 2S2, O3. After that H2S2 is common. Next is in the place of O3, O4 is there, and then again next in the place O5 is there. H2S2 is common, and again next I told you H2SXO6, where X may be 2, maybe 3, maybe 4, maybe 5. Okay, and also I am telling other oxo acids. Then H2SO4 common, H2S2 O7, now you can see O7. Again next is H2SO5, again H2S2O8. Okay, some I will tell this some structure of some oxo acids. Okay, some of these acids are unstable and cannot be isolated because they are very unstable. They are known in aqueous solution. They are known in aqueous solution or in the form of their salt. Okay, just I will tell a structure of a few oxo acids, like sulfurous acid. Sulfurous acid means H2SO3. H2SO3. Then now S is in the middle. S is in the middle, and it has one pair of electron, means 2 electron. S is in the middle and it has one pair of electron, means 2 electron. And here with S, 2 OH bond is there, SOH, and one double bond is there with oxygen, one double bond. Okay, means 2 OH bond is there, SOH, and third, that is the with O double bond. Okay, means 2 single bond, 1 double bond, and on sulfur one pair of electron is there. Okay, all are angular. All whatever I will tell, all are angular. Now next I am telling you sulfuric acid, common, H2SO4. Then again sulfur is in the middle. Now here again 2 bonds are there, SOH, single bond, and two bonds are there, 2 oxygens are there, then 2 bond is there, both are double bond. One is above, other is little down. Okay, then in H2SO4 2 OH is there, 2 OH bond is there, and 2 SO bond is there, but both SO bond is double bond. This is called sulfuric acid, common, H2SO4. Now next I am telling you peroxo disulfuric acid. Peroxo disulfuric acid means H2S2O8. Then now 2 sulfur is there, and 8 oxygen is there. Then out of 8 oxygen, now I will tell you, it is long, but quickly you will understand if you will understand in 2 parts. Okay, actually you think two structure, but both structure will be joined finally. Okay, then two structure means what? H2S2O8 is there, means 8 oxygen is there. Then now you consider two molecules. Then in these two molecules, sulfur is in the middle and 4 oxygen is attached. Okay, total these things 4 bonds are there. S is in the middle. First you consider two molecules and finally you will join to both molecules. Then you will get peroxo disulfuric acid. Then first S is in the middle and total 4 bonds are there. Then it is a two bond is with oxygen, what I discussed earlier, and both are double bond. Both are double bond, and 2 bond is there. 2 more bond is there. Then third bond is also with oxygen, but this is a single bond. Then 3 oxygen I told you, or fourth bond is with OH. Okay, OH. Then now this S is in the middle, 3 oxygen is there. Then 2 oxygen has double bond, and 1 oxygen single bond, and 1 OH bond. This is the, I can say, one molecule that's same. Then other molecule is again same, but it is a left side. Suppose this is the right side, then left side same structure. S is in the middle, 2 oxygen is there, double bond, and third oxygen is single bond, and fourth bond is OH. In both molecules 1 OH bond is there. Then now what you have to do, that now both molecules you have to attach. Then that S and O single bond was there in both molecules. Then now both oxygen, single bond oxygens will come close and they will join. Means 2 oxygen will come in the middle, and left side and right side means 3 bond will be there. 2 double bond, S with oxygen, 2 double oxygen and 1 OH. And this side also, right side, S is in the middle, 2 oxygen is there, double bond, 1 OH. And in the middle now 2 oxygen is there, both are joined by single bond. Quickly you will understand. I will try to send the structure. Okay, this is the peroxo disulfuric acid. Peroxo means, you understand, in the middle OO bond is there, just a peroxide O bond is there, both side HH is there, in the middle 2 oxygen. Same things are here. In the middle 2 oxygen is there, both are joined by single bond. Okay, and with this oxygen, that sulfur remaining atoms are with sulfur 2 oxygen and 1 OH is attached. That is attached with left oxygen, and other bonds, means molecules S, OO and OH, that is attached with that oxygen single bond. That 2 oxygen single bond came in the middle. This is actually peroxy disulfuric acid, because 2 sulfur is there. Now third I am telling you, oleum. Oleum is, question is asked. Its molecular formula is H2S2O7. This is also called pyrosulfuric acid. Pyrosulfuric acid. Now here it is very easy to understand the structure. Here in the middle only 1 oxygen is there. In peroxo you have seen 2 oxygen was there, but here only 1 oxygen in the middle. And right side, left side, that same sulfur is joined. One is in the left side, other is in the right side, and with S same things, that 2 oxygen is joined with double bond, SO double bond, and 1 OH bond. Same way right side, S is joined with 2 oxygen. Both are double bond and third bond is OH. This is called pyrosulfuric acid. Now I will tell about the sulfuric acid. Sulfuric acid, how it is manufactured. This is very, very important. Okay. Actually, this is manufactured by contact process. They will ask the name of the process. Then sulfuric acid is manufactured by contact process, which involve 3 steps. Okay. Sulfuric acid is one of the most important industrial chemicals worldwide. Sulfuric acid is manufactured by the contact process, which involve 3 steps. First step is burning of sulfur or sulfide ores in air to generate SO2. Second step, conversion of SO2 to SO3 by the reaction with oxygen in the presence of a catalyst. Catalyst is here V2O5. And third step, after now we got the SO3, then third step, absorption of SO3 in H2SO4. Actually, H2SO4 is a dehydrating agent. Okay. Remember always, H2SO4 is dehydrating agent. It can absorb the water molecules. But third step here you can see absorption of SO3 in H2SO4. H2SO4 will absorb SO3 and it will form oleum, means H2O7. Simply you add SO3 plus H2SO4. Then now 2H is there. Now 2 sulfur is there. SO3 and H2SO4. Then 2 sulfur is there. Then it becomes H2, and oxygen is SO3, 3 oxygen, H2SO4, 4 oxygen, total 7. Then oleum is H2, H2O7. You got oleum, and from the oleum you will get H2SO4. Then this is the 3 main step. Okay. The SO2 produced, SO2 in the first step, what you got, the SO2 produced is purified by removing dust and other impurities such as arsenic compounds. With SO2, arsenic compounds may be present, some dust may be present. That is removed actually. Now reaction, what I told you, very simple reaction is there, 2SO2 plus O2. It will give 2SO3 in presence of V2O5, and heat of reaction is minus 196.6 kilojoule per mole. It is exothermic reaction. Heat will evolve. Delta H, heat of reaction, that is equal to minus 196.6 kilojoule per mole. This reaction is exothermic, reversible and forward reaction. Okay, this reaction is exothermic, reversible, and the forward reaction leads to a decrease in volume, because 2SO2 plus O2, total 3 molecules are there, or 3 moles are there. 2SO2 plus 1 O2, total 3, and product is only 2SO3, means 2 mole. 3 moles are giving only 2 mole. That's why there is a decrease in volume. Therefore, low temperature and high pressure are the favorable condition. According to the Lee-Chatterjee principle, because volume is decreasing, then it is suitable. Volume is decreasing means it will happen only at high pressure. High pressure. That's why here high pressure is required, and low temperature is also required, because it is exothermic reaction. Already heat is evolving. Then why will you supply the heat? But some heat is required. Okay. Hence low temperature and high pressure are the favorable condition for maximum yield. But the temperature should not be very low. Otherwise rate of reaction will become slow. You know that rate of reaction depends upon temperature. Hence it should not be very low. Otherwise, rate of reaction will become slow. In practice, the plant is operated at a pressure of 2 bar. Atmospheric pressure 2 bar. And the temperature is maintained at 720 Kelvin. Remember, 2 bar and 720 Kelvin. The SO3 gas from the catalytic converter, you will get a SO3 in catalytic converter, and that SO3 is absorbed in concentrated H2SO4 to produce oleum. And after that, what will you do? Dilution of oleum means you will mix water in that. Dilution of oleum with water gives H2SO4 of the desired concentration. Okay. In the industry, 2 steps are carried out simultaneously to make the process a continuous. Okay. And also it will reduce the cost. Means SO3 plus H2SO4, it forms H2O7. Okay, it's a diagram, flow diagram for the manufacture of sulfuric acid. I will send you. Reaction now you are knowing. Quickly you will understand that sulfur burner will be there, and it will burn in presence of oxygen, and it will go after that in the next chamber. It will go, that is the washing and cooling tower. And there we have to wash with water. Then there actually it will convert to actually H2. Third means first sulfur burner will be there. One you can say main part. Second part is you can say washing and cooling tower. Third is drying tower, and fourth is just to purify the SO2 gas. Then arsenic purifier containing gelatinous hydrated ferric oxide, that will be there just to purify, to remove dust and arsenic. Okay. Then after that, now pure SO2 you got. Then it is sent to the actually before sending you have to heat it. Preheater will be there. There you will heat it and you will send to the next tower. That is called catalytic converter. In that V2O5 will be there. Means till now what did you have done? You got sulfur dioxide. From the sulfur dioxide plus O2 you have passed to the second tower, and in that you have sprayed the water, correct? And third you have sprayed with H2SO4. Then you will get dry SO2. Okay, you will get dry SO2 because H2SO4 spray will absorb the H2O if any. Then you will get dry SO2, and there you will mix with oxygen, or oxygen from the beginning may be there. Then now dry SO2 plus O2, that will you pass through arsenic purifier. You can say purifier will be there, arsenic purifier containing gelatinous hydrated ferric oxide. Then before sending to catalytic converter, it is heated in preheater, and after that in catalytic converter, by name it is clear, catalyst will be there, V2O5. Then now whatever SO3 you got, now pure SO3, that is passed in a last tower, and in there actually concentrated H2SO4 will be there. Then now SO3 plus H2SO4, it will form oleum. Okay. Then this I have discussed flow diagram of the manufacture of sulfuric acid. Now properties, I want to tell properties. Sulfuric acid is a colorless, dense, oily liquid with a specific gravity of 1.84. You always remember specific gravity of sulfuric acid, it is asked 1.84 at 298 Kelvin. The acid freezes at 283 Kelvin. It is not 283 means what? Kelvin is there. Means 273 plus 10, 283, 10 degrees centigrade. Correct? The acid freezes. It will freeze at 283 Kelvin means 10 degrees centigrade and boils at 611 Kelvin, 611 Kelvin. Okay, if you want to know the degree centigrade, then minus 273 you do. You will get in degree centigrade. Then this H2SO4 dissolves in water with the evolution of large quantity of heat. Now keep in mind, very in lab you should be very careful. It dissolves in water. H2SO4 dissolves in water with the evolution of large quantity of heat. Hence, care must be taken when preparing sulfuric acid solution from concentrated sulfuric acid. Never add water in sulfuric acid. Never. Then what we will do? If you want to dilute, then a concentrated acid must be added in water, not reverse case. Otherwise, explosion will take place. Okay. The concentrated acid must be added slowly into water with constant stirring. Never add water in sulfuric acid. Okay, reverse you can do. In concentrated sulfuric acid, you can add in water to make a dilute solution of sulfuric acid. And then slowly you have to add and you have to stir continuously. Means the concentrated acid must be added slowly into water with constant stirring. The chemical reaction of sulfuric acids are result of the four characteristics. Due to four regions, chemical reaction is due to the four regions. First, due to low volatility, low volatility. Second, due to a strong acidic character. Third, a strong affinity for water. H2SO4 has a strong affinity for water, don't forget. That's why it is called dehydrating agent. And fourth, ability to act as an oxidizing agent. Then chemical properties depend on these four characteristics. Then I am telling about the in aqueous solution. Aqueous solution, sulfuric acid ionizes in two steps. Means H2SO4 plus H2O. Then H2SO4 will lose one hydrogen and H2O will become H3O plus hydronium ion. H3O 1 plus is called hydronium ion. Then now what will remain? H2SO4 was there. Now it will remain HSO4 1 minus. Then this reaction goes fast. H2SO4 plus H2O, it gives hydronium ion means H3O plus HSO4. Right, it will be an aqueous solution. And K value, dissociation constant of H2SO4 acid is very large. Ka value is greater than 1. This is the first ionization. That is the one you are writing, Ka1, first ionization. Now HSO4, one more H is there. Then this HSO4 plus H2O, it will again take this H2O, again it will take that hydrogen. Then now it will make again H3O plus hydronium ion. Now it will give SO4 2 minus. SO4 2 minus, but it is slow. Then now its Ka value, now we can tell second ionization 2, Ka2, its value is less, 1.2 into 10 to the power minus 2 less. Then first ionization value is more than 10. That's why it is stronger. If K value is more, means acid is strong. By seeing the value of K, you can tell which acid is strong. Okay. Same way base also you can compare. More the Kb value, more the basic. Okay. Then by comparing base, Kb value can tell about the base also. Then now come to the here acid only. Then greater the value of dissociation constant, stronger is the acid. Okay. There K dissociation constant you can tell K. The acid forms two series of salt. Acid means H2SO4 forms two series of salt. Acid is there, then with reaction with base it will form the salt. Acid plus base equal to salt. Then it forms two types of salt. H2SO4 forms two series of salts. First, normal sulfate. Normal sulfate, just simply sodium sulfate, potassium sulfate, copper sulfate. This is a normal sulfate. And other is acid sulfate. Acid sulfate means sodium hydrogen sulfate. Means 2H is there. If only one H is replaced with sodium, potassium, then one hydrogen will be remaining with acid. That's why it is called acid sulfate salt. Okay, acid sulfate salt means sodium hydrogen sulfate, potassium hydrogen sulfate, etc. Sulfuric acid, because of its low volatility, can be used to manufacture more volatile acids from their corresponding salts. Means from the salts you can get the acid. General reaction I am telling you. Suppose 2MX. M means metal, X may be you can say chloride, bromide, iodide, like that way. Then 2MX plus H2SO4, it will form 2HX plus M2SO4, where X is equal to, X may be fluorine, fluoride ion, chloride ion, nitrate ion, etc. And capital M is metal. Okay, 2MX plus H2SO4, it gives 2HX plus M2SO4, where M is the metal. Concentrated sulfuric acid is a strong dehydrating agent. Remember, always question is asked. Concentrated sulfuric acid is a strong dehydrating agent. Many wet gases can be dried by passing through sulfuric acid. If any gas is wet, then it is, if it will be sent through the H2SO4, that will become dry, provided the gas do not react with the acid. Sulfuric acid removes water from organic compounds. It is evident by its chairing action on carbohydrate. Actually, it removes water from the organic compound. As for example, that is the sucrose, C12H22O11. This is actually carbohydrate, but name of the carbohydrate is sucrose, ordinary sugar, what we are using daily, C12H20O11. If you will add H2SO4 in this sugar, in a beaker you take this sugar, add H2SO4, concentrated H2SO4, then C12H20O11 is there. Then H20O11 means 11H2O, water is attached with organic compound. Then that 11H2O will be absorbed by the sulfuric acid. Only you will, in beaker you will find only carbon, black carbon you will get, because H2SO4 absorbed this H22O11 means 11H2O, it absorbed. Hence C12H22O11, if you will add H2SO4, it will absorb water molecules and it will give 12 carbon plus 11 H2O. Hot concentrated sulfuric acid is a moderately strong oxidizing agent. Again you remember, hot concentrated sulfuric acid is a moderately strong oxidizing agent. In comparison, again important things question is asked, I am telling you. In this respect, it is an intermediate between phosphoric and nitric acid. Both are oxidizing agent, phosphoric acid and nitric acid. Then phosphoric acid is more oxidizing agent. Correct? And this, if you will compare all three, phosphoric acid, nitric acid and sulfuric acid, then sulfuric acid will come in the middle, intermediate between phosphoric and nitric acid. Question is asked. Both metals and non-metals are, next reaction I am telling you, both metals and non-metals are oxidized by concentrated sulfuric acid, which is reduced to SO2, means Cu plus 2H2SO4, concentrated H2SO4, you will get CuSO4 plus SO2 plus 2H2O. Second, sulfur you take example. Then sulfur 3S plus 2H2SO4, you will get again SO2, means 3SO2 plus 2H2O. Water is common, SO2 is also common. Then first reaction I told you, Cu plus 2H2SO4, CuSO4 plus SO2 plus 2H2O. All here in all reaction H2SO4 is concentrated. Now third reaction, carbon plus 2H2SO4, carbon plus 2H2SO4, everywhere 2H2SO4 you have used. Balanced reaction is easy. Then C plus 2H2SO4, here again you will get SO2. In all three reactions you got SO2 and water. Okay, and one for the main product is carbon dioxide. Then C plus 2H2SO4, you will get CO2 plus 2SO2 plus 2H2O. Okay, then this I have told you about the properties of H2SO4. Now application I am telling you. Uses. Sulfuric acid is a very important industrial chemical. A nation's industrial strength can be judged by the quantity of sulfuric acid it produces and consumes. It has so much importance. Industrial strength can be judged by production and consumption of H2SO4. It is needed for the manufacture of hundreds of other compounds. This H2 manufacture I am talking about, many compounds are manufactured with the help of H2SO4. It is needed for the manufacture of hundreds of other compounds and also in many industrial processes. The bulk of sulfuric acid produced is used in the manufacture of fertilizer. Don't forget, fertilizer. Example of fertilizer is ammonium sulfate. Second example is superphosphate. These are the sulfates. Other uses are, I am telling you, first in petroleum refining. Second use is in manufacture of pigment, paints, dyestuffs, intermediates. Okay, and next application is in a detergent industry, and again other use is in metallurgical application. As for example, cleansing metals before enameling. For enameling, metal must be cleaned. Then it is used by H2SO4, by use of H2SO4. And in electroplating also it is cleaned by H2SO4. and in galvanizing also it is used. And again other very important is in a storage battery. All motorcycle, car, in almost all vehicles that storage batteries is used. In that H2SO4 is used. Next application is in the manufacture of nitrocellulose products. Actually this nitrocellulose that I told you that in these things in water filter maybe generally film will be made up of nitrocellulose. Okay, and many other everywhere nitrocellulose products are used, and in general as a laboratory reagent. And this I have discussed all applications, all important application of H2SO4. Now I am stopping only here. Okay, thank you.